Good morning, everyone. You're watching the fifth lecture. The last lecture, we tried doing a few questions from previous year JEE Advanced and Mains papers. So, a few suggestions from your side were to do questions from NEET from the medical side as well. Looking forward, I'll try to do that. And someone wanted me to find out the moment of inertia of a non-uniform rod. So the reason I did not do that previously is because you were not good enough with integration. So today's class we will do the moment of inertia of a non-uniform rod. One more thing to clarify to the person who asked me if the moment of inertia in the case, like when I was talking about the parallel axis theorem, so you pointed out is the moment of inertia of half of an object or half of that object. Look, at that point of time, I just clearly clarified in that video. I say that the moment of inertia is of that sphere. I took that example to show you how to use the parallel axis theorem. It was not the answer to the entire problem, but I think now you already know because you've watched all the remaining lectures. You know how to apply the parallel axis theorem. So that's the clarification. ठीक है तो आज का क्लास शुरू करते हैं लेट्स फर्स्ट ऑफ ऑल ask you a JEE mains question, a a JEE advanced question from 2015. I'm not very sure if it's a mains or an advanced question. Don't bother with that. There is a sphere. Okay, so there is a sphere of radius r and mass m. There is a sphere of radius r and mass m, and out of this sphere, a cube of maximum volume is cut. A cube of maximum volume is cut. So you take this sphere, and from this sphere, you somehow manage to, have a cube inside this sphere, and then you cut the cube of maximum possible volume out of it. Okay? The question over here is to find out what is the moment of inertia of the cube. So I hope you get it. There is a sphere, and from the sphere, you are cutting a cube of maximum possible volume. So keep in mind, if you're trying to cut a cube of maximum possible volume, there can't be many cubes because the cube has a very unique property that all the sides have to be equal. So the simplest thing you have to do is, let us say the side of the cube is S. So if the side of the cube is S, what is the diagonal of the cube? So the diagonal of the cube is going to be S square plus S square plus S square, S root 3, right? So the diagonal of the cube will be equal to S root 3. Just letting you know, for those people who are not so good with geometry, the diagonal of the cube will be equal to S root 3. This has to be equal to the diameter of the sphere. So this has to be equal to 2r. So you have S is equal to 2r divided by root 3. Now, because you're cutting a part of a cube, then it is also going to have a part of the mass of the sphere, right? You're cutting a cube out of a sphere. So the mass of the cube is also a part of the mass of the sphere. I think you understand what I'm saying. Okay, when you cut a very small disk out of a bigger disk, we find a ratio. To use the ratio method, okay, use the ratio method to find out the mass of the cube. It's not a particular method, but I call it the ratio method because you're dividing two things. It's a very quick way to find out the mass. So use it to find out the mass of the cube. Once you find out the mass of the cube, now you find out the moment of inertia of this cube. So you can pause the video and you can try it on your own. I'll continue solving it beyond this point. Okay, pause karo, give it a try. सबसे पहले, what is the mass of the cube? The mass of the cube is proportional to the volume of the cube. Okay, these are three-dimensional objects. It's proportional to the volume. So let us say the mass of the cube is equal to small m. So you can write small m is proportional to the volume of the cube, which is s cube. So m is proportional to s cube. What is the mass of the sphere? The mass of the sphere is proportional to 4 by 3 pi r cube. Okay, so now you replace s cube with the actual value. So what is the actual value? 2 into 2, 4 into 2, 8 r cube divided by 3 root 3. Now you divide both of them. If you divide a proportionality with a proportionality, you get an equality, right? So you will get m divided by n is equal to r cube, and r cube are going to cancel. So you're going to get 8 divided by 3 root 3. और नीचे कितना आएगा 4 pi divided by 3. So 3 is going to cancel. 4 2s are 8. So you will get 2 divided by pi root 3. So this implies that the mass of the cube is going to be the mass of the sphere times 2 divided by pi root 3. That's the first thing. So now we know what is the mass of our cube. The cube का mass अब हमें पता है. Now the remaining thing is to find out what is the moment of inertia of a cube. Keep in mind, a cube is a three-dimensional object. But whenever you're trying to find out moment of inertia, this concept is important to you. Whenever you try to find out moment of inertia, you always take perpendicular distance from the axis. Okay? It doesn't matter how thick some object is. When we talked about a disk is like a biscuit, right? So, or a cake. A cake is also a biscuit. I mean, it's also a disk. Okay, cake is not a biscuit. So, if you try to find out the moment of inertia of a disk, then the thickness of the disk does not matter, right? So, when you try to find out the moment of inertia of a plate, the thickness of a plate doesn't matter. It obviously matters in finding out the mass, but otherwise, in finding out the moment of inertia, it doesn't matter. A cube is a very thick plate. Think of a cube as a very thick plate. So, in the last class, towards the end, I proved that the moment of inertia of a plate is equal to 1 by 12. Okay? Moment of inertia about the center of the plate is equal to 1 by 12. Mass of the plate into a square plus b square, where a and b are the length and width of that plate respectively. In this case, 1 by 12 is obviously 1 by 12. The mass is m into 2 divided by pi root 3 multiplied by both a and b are equal to s. Here a and b are both equal to s. So first of all, a square plus b square is going to become 2 times a square. A is equal to s, so this is multiplied by the square of s. So what is the square of s? 4r square divided by root 3 ka square, which is just 3. Okay, so try to calculate what's remaining. You will have 2 times 2 is 4. 4 threes are 12. So 4 into 3 is 12. So you have 2 into 2 is 4. You have m, you have r square. So you have m, you have r square divided by 3 times 3 is 9 into pi into root 3. So you have 9 into root 3 into pi. So what is the moment of inertia of the cube? The moment of inertia of the cube is 4 mr square divided by 9 root 3 pi. This question as it is, I asked you, belongs to 2015. Okay? You can go back and check this question over there. So did you understand? We took a sphere. We found out the mass of the cube. The largest possible cube is like a very unique thing. The diagonal of the cube must match the diameter of the sphere. And then from that, we calculated the moment of inertia with the important concept that the thickness of an object or the length of an object parallel to the axis doesn't matter. So in this problem, that is what is important. The one thing you should understand in this problem is that the length of an object parallel to axis of rotation. The length of an object parallel to the axis of rotation does not matter. So the best way to remember this or to reason this out in your head, the moment of inertia of a cake and the moment of inertia of a biscuit of the same size and mass is going to be the same. The thickness does not matter. So a cube can be considered as a thick plate. The thickness will not matter. Okay? So that's the first thing I wanted to teach you today. So that's it. Okay. Another question. Say that you have a square. So this question has come up once or twice in JEE. actually twice. So there is a square, and in the square we take a few different axes. Okay, so we take an axis like this, then we take an axis perpendicular, we take an axis in this direction. Okay, like this we take an axis, and then finally we are taking another axis in this direction. So in a square we have a few different axes. Let's call these as, let's say, 1, 2, 3, and 4. So the question is asking you that out of all these axes, which of the following relations are correct? So I'm going to give you some, but I think you'll get the idea from here itself. So one relation is I1 is equal to I4. More than one option could be correct. Second one, I1 plus I2 is equal to I3 plus I4. Just giving you the options, you can keep reasoning. Okay. I1 plus I3 is equal to I2 plus I4. Okay. And finally, I1 is equal to I2 is equal to I3 is equal to I4. Which of these options is correct? First of all, to solve this question, what do you need? The moment of inertia of a square or a square plate about this point is 1 by 12 m a square plus b square. All of these axes are perpendicular to that axis. This axis is coming out towards you. Like imagine putting a player, like a pen on the screen of your phone. So that is the axis. All of the axes in the figure, they are perpendicular to that axis. Okay, this thing should be clear to you. Now keep in mind that whenever you are taking an axis to apply the perpendicular axis theorem, both the axes should be perpendicular to each other. So what you can do is you can group together two axes, like you can group together the axis 2 and the axis 4. You can group both of these axes together, axis 2 and axis 4. And then you can write that I2 plus I4 is equal to the moment of inertia of this square plate. I2 plus I4 is equal to the moment of inertia of the square plate. You could also write that I1 plus I3 is equal to the moment of inertia of the square plate. How are you able to write this? Because of the perpendicular axis theorem. I never said that the axis should be perpendicular to some side of the object. No, the axis should be perpendicular to each other. Two of the axes should lie in the plane of the object, and the third one should lie perpendicular to the plane of the object. After that, you can write I1 plus I2 is equal to the moment of inertia through the third axis, whichever the third axis is. So you can write I2 plus I4 is equal to I0, or I1 plus I3 is equal to I0. After this, the concept is of symmetry. If you remember, symmetry का मतलब होता है same. So I1 and I3, they are the same thing, right? Like, you're passing through the middle of the square. I1 and I3 are the same thing. I2 and I4 are also the same thing. So with that understanding, you can say that I2 and I4 are equal to each other. And in addition to that, I2 plus I4 is equal to I0. So that implies that I2 is equal to I0 divided by 2. That is also the value of I4. I4 is also equal to I0 divided by 2. That also implies to I1. I1 is also equal to I0 by 2. I3 is also equal to I0 by 2. सबका value same है. Even if I1 is like for a D kind of a shape, half of a square, and I2 is for a triangular shape, both of their moment of inertia is half the moment of inertia of a square plate. We just proved it. So because all of these values are equal to each other, clearly option D is correct. I1 is equal to I2 is equal to I3 is equal to I4. Now, I1 plus I3 is equal to I2 plus I4. From here itself, we can see that option C is also correct. That's just the perpendicular axis theorem. I1 plus I2 is equal to I3 plus I4. So I1 plus I2, that is not the perpendicular axis theorem. But if you still write down the values, I1 plus I2 is equal to I0. I1 plus I2 by substituting the values, like, by using the values, not by using the theorem. By using the values, it appears to be equal to I0. Same goes for I3 plus I4. So even option B is also correct. Option B is also correct. What about option A? Is I1 equal to I4? Yes. So A is also correct. So in this question, all the four options, they happen to be correct. There are some variations of this question. So the question, like I told it to you, I don't exactly very clearly remember which year this came in. I think it came in 2013, 2012 sometime. So this is a question. Okay. So this is based on the perpendicular axis theorem and a square. So I'll show you more questions when I come across them or when they are relevant to the class. Now let's address a question that you asked me. What is the moment of inertia of a non-uniform rod? So not only will we find out the moment of inertia of a non-uniform rod, we will also find out the moment of inertia of a sphere that is not uniform. So the question about the sphere came in JEE Advanced 2015. So we'll come to that question slightly later. पहले तो ये समझो कि रॉड का कैसे निकालते हैं. नॉन यूनिफॉर्म रॉड. What is non-uniform in a rod? In a rod, two things can be non-uniform. First of all, the shape of the rod could be non-uniform. Okay? There are two things about every object. There is the shape of the object, the geometrical shape of the object, and also there is the density of that object. दोनों में से कोई भी चीज, या even both of the things could be non-uniform. So first of all, try to get this concept. Imagine that you have a rod. I'm going to draw the rod the same way in both cases in purple color. Okay? Now I want this rod to be a non-uniform rod. So what I can do is I can increase the radius of this rod. Instead of the radius remaining constant, I can increase the radius of this rod and I can end up with a conical shape. So in this case, a cone is a non-uniform rod, or it is a rod with increasing radius. A cone is a non-uniform rod, or it is a rod with increasing radius. It's a non-uniform rod. We'll find out the moment of inertia today. Okay? The other kind of non-uniform rod is the one that you probably meant when you asked me the question, that there is a non-uniform rod and its density is increasing. So here the density of the rod is slightly less. So as you go forward in the rod, the density of the rod is increasing. Okay? So as you go forward, the rod becomes very, very dense, and here the density is like sufficiently very high. So in this case, the shape of the rod is constant. However, the density of the rod is increasing or it is changing. So density is dependent on position. So in this case, this is a rod of non-uniform density. This is the easier question and we will first try this one. So let us say in a rod, the density is given by some value rho 0 multiplied by x, where x is the position of some point in the rod, divided by the length of the entire rod, which is equal to L. So let us say there is a rod of length L whose density changes with respect to position as rho 0 x by L. That's the first question we'll solve. And this is the second one that we'll be solving. The moment of inertia of a cone. Let's start with that one. A rod with non-uniform density. A rod with non-uniform density. Non-uniform means not constant. Non-uniform density. ये तुम लोग कर लोगे, ठीक है? Don't be scared of integration. You can easily do it. So first of all, you take your rod and then you say that in my rod, the density is changing with position. So you take a position also, x. What is the length of the rod? The length of the rod is equal to L. So with this position x, you say that at this point, the density is equal to rho 0 into x divided by L. Keep in mind, my rho 0 is not a volume density. This is a mass per unit length. This is a mass per unit length, which means that if I simply multiply the length, I will automatically get the mass. Okay, just keep that in mind. What is your first step? Your first step is to take a mass element. So first of all, you take a mass element. This is your first step. Take a mass element. A mass element is a very small part of an object. Take a mass element. its mass is dm, correct? If the rod was uniform, you would apply the ratio method. The ratio method only applies when something has uniform density. That is the point of ratio. A part of the mass of the rod is in my element. But here, even though a part of the mass of the rod is in your element, the mass depends on where you are in the rod. Okay, so you just cannot write m by m. Cannot do that. What is the size of this element? This is dx. Why is it dx? If you add small parts like this, then you will get the entire length of the rod. X is going to increase. If you add this element, then x is going to be till here. You add another element, x is going to come till here. Add another element, x is going to increase. So each element changes x. That is why the size of the element is dx. Okay. So dm is equal to density multiplied by length. So what is the density? Rho. What is the length? Dx. So dm is equal to rho dx. If you want, you can put the value of rho over here. So it is equal to rho 0 into x by L multiplied by dx. That is your first step. What is your second step? Step 2 is to write the moment of inertia of that small part. So just to clarify, I did not tell you yet where is my center. My center is at the edge of the rod. Okay? My center is at the edge of the rod. So from here, I'm going to find out my moment of inertia. That is my 0 point. I'm measuring all the distances from the axis. Should have mentioned this at the beginning. The axis is at the edge of the rod. All distances are perpendicularly measured from the axis. Okay? So that's the edge. Now, what is the moment of inertia? So di is equal to, it is a point mass. A mass element over here is a point mass. So we will write r square into dm. So r square is equal to x square and dm is just dm, rho 0 into x by L into dx. Okay. What is the third step? The third step is to integrate this to find out the actual moment of inertia of the rod. So what is the range of x? The range of x is to go from 0 to L. X ka minimum value is 0. The maximum value of x is L. So step 3 is to integrate to find out the answer. So moment of inertia is equal to integration of di is equal to integration of rho 0. I'm combining the value of x. So rho 0 divided by L, x square times x is equal to x cube dx. You're integrating from 0 to L. It is simple. Take rho 0 by L outside. Okay. X to the power n dx is x to the power n plus 1 divided by n plus 1. And you integrate from 0 to L. So what will you get? Rho 0 divided by 4L. And the only thing you will get is L4 because 0 to the power 4 is basically 0. So you'll get rho 0 L cube divided by 4. That's your answer. So did you get it? A rod with non-uniform density, it's pretty simple. What you do is the same three-step process. Step 1, step 2, step 3. What is step 1? You take a mass element. Except in this case, you cannot take a mass element and just write and use the ratio method. Cannot do that because that only applies for a rod with uniform density. In this case, what you will do is you will find out, like I found out over here, dm is equal to rho into dx. Step 2, di is equal to r square into dm. Because our mass element is a point mass, write the moment of inertia of a point mass. If it was a ring or something else, we will also do that today. So you will write the moment of inertia of that thing. Okay. Also write the range. So once you're done with step 2, step 3, to find the moment of inertia, you will have to integrate. So you integrate, simple integration normally, and then you find out your answer from that. Okay. Now let's go to our second problem. The second problem was to find out the moment of inertia of a rod with non-uniform radius, or basically that of a cone, the moment of inertia of a cone. So first of all, you draw your rod and you give it a non-uniform radius. So it becomes kind of like a frustrum. This thing is called as a frustrum. It's a part of a cone. It's a frustrum. Okay. Now, let us say the initial radius of the rod is equal to A and the final radius of this rod is equal to B. This is the initial radius, that is A. The final radius is equal to B. So this uh, accommodates a lot of objects like a bucket, ice cream cone, many things. So don't go with the idea that it's a rod. Geometrically, it's a rod with increasing radius. The length of this thing is equal to L. The length is equal to L. And we want to find out the moment of inertia of this rod. The question is about which axis. You want to find out the moment of inertia about which axis. So first of all, I'll stick to the axis that we had in the previous problem. I'll stick to the edge of the rod. I'll stick to the end of the rod. So this point is my axis. I'll stick to the edge of the rod. My axis is this one. Okay, that's my axis. But we can also find out the moment of inertia about this horizontal axis as well. So we will also do this. We will find out I2. We will also find out the value of I1. So let us start with I1 initially. We are not doing I2 right now. Find the moment of inertia of this rod about axis I1. We have to take a mass element. So if you take a cut section of this rod, what is a cut section of this rod going to look like? It's not going to look like a point. It is going to look like a disc. Think of a carrot. If you cut a carrot and you take a slice of a carrot, it's going to look like a disc. So if the position of this thing is equal to x, the radius of this thing will be something we don't know. It's equal to r. Its thickness will be equal to dx. Its mass will be equal to dm. So all of these properties apply to this. It's a disk of radius r. Its thickness is dx and its mass is dm. So step 1, you write down the value of dm. Write down the value of dm. In this case, what do you think dm is going to depend on? dm is going to depend upon the volume of that slice. Keep in mind the rod has uniform density. It doesn't have non-uniform density, it has uniform density. So we can apply the ratio method. Let us say that the entire rod has a mass of m. Okay. I hope you know how to find out the volume of a cone. The volume of a cone is equal to 1 by 3 pi r square h. So let us say that the entire rod has a mass of m. If you don't know how to find out the volume of a cone, we can just make this question slightly simpler and say that the density of this thing is equal to rho. Let's keep it simple. The density of the material is equal to rho. So in this way, we can directly find out. So what is the value of dm? dm is equal to density into volume. Volume will be dv, part of the volume. So what is the volume of the slice? The volume of the slice, it's basically a circle. So it is pi r square multiplied by the thickness, which is dx. समझ में आया? dm is equal to rho into pi r square into dx. Volume is equal to area times length. Now the question is, what is the value of r? To find out the value of r, you'll have to use a little bit of geometry. Draw a straight line. You will have two triangles. One is this small triangle and one is this bigger triangle. Both of these triangles are similar to each other. What is this length? B minus A, because the entire length is B. Part of it is A. This much is always A. So that in that triangle, you can write that that small length is B minus A. Same way, this is equal to R minus A. So you can write R minus A divided by the base of this triangle. The base of this triangle is equal to x, is equal to the height of that bigger triangle, which is equal to b minus a, divided by the base of that triangle, which is equal to L. So what is the value of R? R is equal to A plus b minus a into x divided by L. So for the time being, what we will do is we will call this term as C. ठीक है? So we can write that R is equal to, यहाँ पे अपन लिख सकते हैं that R is equal to A plus CX, not just B minus A. I'll expand that term to mean everything. B minus A by L. This entire term is called as C. ये जो पूरा term है, this entire term is called as C, just for the case of simplicity. So we can write A plus CX. It will be simple for us to calculate. In the end, we can substitute. So that's your first step. The next step is to write down the moment of inertia. So step 2 is to write down the moment of inertia. Now, what is the moment of inertia of this disk equal to? The moment of inertia of a disk is half mr square. But about which axis? The axis should pass through the center of the disk and be perpendicular to it. If the axis passes through the diameter of the disk, in the last class we saw that the moment of inertia is equal to 1 by 4 mr square. ठीक है. So first of all, in this disk is over here. The axis is going to pass through the diameter. The axis is passing through the diameter of the disk. So that moment of inertia is 1 by 4 m into r square. Our axis is actually at a distance of x. So we have to first of all apply the perpendicular axis theorem. We also have to apply the parallel axis theorem. So di is first of all equal to 1 by 4 dm into r square. That is by the application of the perpendicular axis theorem. In addition to that, the mass of the disk is equal to dm. The distance from the axis is equal to x. So dm into x square. So understand this. This part is from the parallel axis theorem and that part is from the perpendicular axis theorem. Both of these are getting applied over here. So you will need to solve this a little bit. So we can write di is equal to 1 by 4. I think we can take dm common. So 1 by 4, let it be. Let 1 by 4 be inside. So dm into r square divided by 4. So r square divided by 4 plus x square. This is the value of di. Now step 3. So I'll have to turn the page. Step 3 is to integrate. So step 3 over here, you integrate. So you will be writing I is equal to integration of di, which is equal to the integration of dm into r square divided by 4 plus x square. It might look like there are two variables, but r depends on x and only x ranges from 0 to L. So you integrate from 0 to L. Did you understand everything till this point? First of all, ask yourself this, because there's a lot of geometry. The slice is not a point mass, it is a disk. So the mass is of the disk. I simplified the problem by giving you density rho. Otherwise, there would be some more calculation about ratio. So I simplified it by just giving you the density. In step 2, did you understand perpendicular axis theorem, parallel axis theorem? We are applying both of it. दोनों apply कर रहे हैं. The disk, if the axis was passing through the disk, then we would say it is just half m r square. But the axis is passing through the diameter of the disk, and that is why it is 1 by 4 m r square, perpendicular axis theorem. Not only that, the axis is not passing through the disk, it's actually passing through the end of the rod. So the distance between it is equal to x. So that is why we also have to apply the parallel axis theorem. We have to apply both of it. Okay? And that is how we got to this point. So di is equal to dm into r square by 4, which comes from the moment of inertia of the disk, plus mx square. So it comes from the parallel axis theorem, both. What is the value of r? R is equal to a plus cx. Put that value over here. Actually substitute all the required values. You'll have to substitute the value of dm first. The value of dm is rho into pi into r square into dx. So rho into pi into r square into dx. ठीक है, multiplied by r square by 4, which is equal to a plus cx divided by 4 whole squared. So first of all, what I'll do is I'll substitute everything at once, so I'll not confuse you. R square divided by 4 plus x square. Move whatever is constant out first. So rho is a constant, pi is a constant, move them out. So you will get rho pi multiplied by 0 to L, multiply in by r square. So you will get r to the power 4 divided by 4 plus r square x square dx. Now substitute the value of r over here. So you will need to put the value of r. R is equal to a plus cx, where c is equal to b minus a divided by L from the previous page. Okay. So you will need to put those values over here. So this is equal to rho into pi, integration from 0 to L, r to the power 4, a plus cx to the power 4 by 4 plus a plus cx whole squared x square dx. कर पाओगे इसको? कर तो लोगे? It's kind of easy, but if you like, if you think you're not able to do this, relax, you don't have to do this, it's okay. I wanted to show you how to find out the moment of inertia. What we will do is we will solve this integration by splitting it into two easy parts. This part and then something that is very similar to that part, over here. Okay, that's the way of solving this integration. So this integration can be directly written as a plus cx whole to the power 5 divided by 4 into 5. So that is 20. There is a c with x that will also get divided. So that is the integration. A plus cx to the power 5 divided by 20c. To solve this integration, we will have to first of all open the bracket. So you will get a square multiplied by x square. Then you will get 2acx multiplied by x square. And then you will get c square x square multiplied by x square, which is x to the power 4. So the integration of that thing is a square x to the power 3 by 3 plus 2ac x to the power 4 by 4 plus c square x to the power 5 by 5. Okay, don't worry. It's okay. Integration happens to be a little bit long. It's not a big deal. You just have to be patient and you have to do it. It's not a big deal. ठीक है? तो अब क्या करना है? We just have to put it together. Don't give up right now. We just have to put this entire thing together. So you will write rho into pi. So I'm going to assemble the terms. Rho into pi. This is the integration of the first term. I'll write all the remaining terms here. A square x cube by 3 plus 2ac x to the power 4 divided by 4 plus c square x to the power 5 divided by 5. Okay, that's all the terms from the right side put together. Now we have to simply integrate this from 0 to L. So basically if you put 0, you'll get nothing. We have to integrate this from 0 to L. Just need to put L because if you put 0, you won't get many terms anyway. So you put L first. So you will get A plus CL. Keep this in mind. You will get A plus CL. So what is A plus CL? That is equal to B. A plus CL, rearrange the terms over here. That's just equal to B. So the first term will be equal to B to the power 5 divided by 20C. Now the next term will be a square x cube divided by 3. So you will get a square L cube divided by 3 plus 2ac x to the power 4. So you'll get 2ac L to the power 4 divided by 4. The last term will be c square x to the power 5. So you'll get c square L to the power 5 whole divided by 5. That's the first term if you put L. Now if you put 0, this term, this term, this term is going to become 0. But if you put 0 over here, you'll get a to the power 5 divided by 20c. Okay? It appears to be a very long and crazy calculation, but this is how you find out the moment of inertia of a cone or something like that with non-uniform radius. Okay? The density is constant, but the radius is not constant. At this point, there are ways to simplify this calculation. Over here, you can simplify. It is b to the power 5 minus a to the power 5. So it is b minus a into b to the power 4 plus a to the power 4 plus like ab cube. You can write that entire thing. You can expand it. But that's up to you. If you want to do that, you can do that. Or you can leave the answer like this. I wanted to show you how to find out the moment of inertia of a non-uniform object. So instead of being scared about the integration, try to learn the concept that's involved over here. You take a slice, you find out the moment of inertia of that slice, and you integrate. This applies to a simple object, it applies to a complicated object. Every object, the method of calculation is exactly the same. ठीक है बात समझ में आया it's not difficult. In this case, the calculation just got very difficult. It's not that difficult always. Still, एक और चीज करते हैं. Find out the moment of inertia about the second axis. This is going to be easy and you're going to like it. Find out the moment of inertia about the second axis. So if you want to find out the moment of inertia about the second axis, you will again have to split it into disks. So I'll first of all draw the figure once again. This time I'm going to draw it like this so that you can understand what we are doing. You will have to split it into disks. So you first of all take a very small element. This element is actually a disk. This disk is going to have radius r, where r is equal to a plus cx, where x is the distance from the edge. Okay? Even if we are trying to find out the moment of inertia about this axis, still x is getting measured from that edge because the radius is changing like that. So r is equal to a plus cx. What is the moment of inertia of a disk about an axis passing through its center? It is equal to half dm into r square. So this is dm and that is the radius of the disk. So you will need to calculate the value of dm. So what is the value of dm? Dm is equal to pi r square into dx, where dx is the thickness of this slice. So that is your step 1. So step 1, dm is equal to pi r square into dx multiplied by the density. The density in this case is constant. What is the next step? Moment of inertia. The moment of inertia is equal to, it is a disk, so you will write half into dm into the radius squared. Look to the left side of the screen. What is the third step? The third step is to integrate. So you will write I is equal to integration of di, which is equal to integration of half, put the value of r square, take a plus cx ka whole square multiplied by dm, which also contains another r square. So it will be equal to pi into rho into dx, again multiplied by r square. So this will become to the power 4. This integration is very easy. Rho pi divided by 2, you will get a plus cx whole to the power 5 divided by 5. So this is going to go from 0 to L. X is always going to get integrated from 0 to L. So I told you the length parallel to the axis will never matter. So X will not matter. L matters because L is like, it decides the mass. Otherwise it doesn't matter. So you can write rho into pi divided by 2 into 5 is 10. So if you put L over here, this will become A plus CL. So that is equal to B to the power 5. If you put 0 over here, it will become A plus C into 0. What is A plus C into 0? That is A. What is A plus C into L? That is equal to B, the radius of this thing here and the radius of this thing there. So this is B to the power 5 minus A to the power 5. Just like I said before, see that there is no L. Because L is parallel to the axis, the L value does not affect the moment of inertia. It doesn't affect the moment of inertia of this cone. This was a much simpler integration. So moment of inertia of my cone is rho pi divided by 10 b to the power 5 minus a to the power 5. What if I had a perfect ice cream cone? If I had a perfect ice cream cone, then A would have been equal to 0. In that case, the moment of inertia of my thing would have just been equal to 1 by 10 rho pi b to the power 5, where this is b. So in general, this is a very it's a very general calculation. You can apply it to a cone, you can apply it to a frustrum, you can apply it to several different things. My goal was to teach you how to find out the moment of inertia of a non-uniform object. The point I'm trying to make is same three-step process. Okay? So I hope you're done with that. We have a JEE question to solve, a JEE Advanced 2015 question to solve. So I have some time left for it. I'll show you that question. So in 2015, they asked that there are two spheres. Okay? There are two spheres, A and B. Both of the spheres, they happen to have the same radius. In both the spheres, they have the same radius. Except in the first sphere, the density at a point R is equal to K into R by R. And in the second sphere, same radius. Okay, same radius. So rho B is equal to K into R by R to the power 5. So it's asking you, what is the moment of inertia of B divided by A? So about the axis, about the center of the sphere, what is the moment of inertia of B divided by A? So the way the question is asked, you will not be able to solve it by using 2 by 5 mr square, because those are the moment of inertias of standard extended objects with uniform density. In this case, you have to take a sphere first of all. I'm going to draw a very big sphere over here. And you're going to take a small part of the sphere. So you're going to take a very small part of the sphere. So a very small part of the sphere, just like peeling the skin of an orange, is a shell. Think of an orange. The inside of the orange, if you remove it, the rest of it is a shell. So it's a shell. So what is the area of the shell? The area of the shell is equal to 4 pi r square. If the radius is x, then the area is equal to 4 pi x square. What is the thickness of the shell? The thickness of the shell is dx. Okay. So the question asks us r. So this distance is r. We cannot take x. So we'll take this distance as equal to r. अपन x नहीं लेंगे, we'll take it as r. So we will write 4 pi r square dr. Dr is a small part of the radius. The question is, what is the volume of that part? So here comes your step 1. Step 1, dm is equal to density multiplied by volume. The volume is equal to area into length. So we will write rho into dv, where rho is equal to k into r divided by r, and dv is 4 pi r square dr. Keep in mind that the only difference over here is in the power. The power over here is 5 and the power over here is 1. So in general, I will say that the power is n. So I will put n over here. If n is equal to 1, that is my first sphere. And if n is equal to 5, that is my second sphere. That way I can just do one calculation and find out the answer for both of them. Step 2. What is the moment of inertia of a shell? The moment of inertia of a shell is equal to 2 by 3 into dm into the radius of the shell squared. What we have is a shell 2 by 3 mr square. So this is 2 by 3 into dm. So what is the value of dm? The value of dm is equal to k into 4 pi, always put the constants together, into r square into r by r to the power n multiplied by another r square. So this will become r to the power 4. That is di. Finally, we'll have to find out the moment of inertia by using integration. So I'm removing the shell over here. You already saw how I found out di. So lastly, we'll have to use step 3. Use integration to find out the moment of inertia. So I is equal to the integration of di. What is the range? R is equal to 0 is the center of the sphere, and R is equal to R is the outside surface of the sphere. So it will be equal to 2 by 3 into k into 4 pi. So that is equal to 8k pi by 3. 8k pi by 3 r to the power n plus 4. Correct? R to the power n plus 4 divided by capital R to the power n. Divided by capital R to the power n. इसको integrate करना है from 0 to r. ठीक है? So what will you get? 8k pi divided by 3r to the power n. They are all constants. R to the power n plus 5 divided by n plus 5. R to the power n plus 5 divided by n plus 5. You go from 0 to r. So you will get 8k pi divided by 3r to the power n. If you put r, if you put 0, you'll get nothing. But if you put r, you'll get r to the power n plus 5 divided by n plus 5. Correct? You already have r to the power n. So if you want, you can cancel the r to the power n and you will only remove the n from the numerator over there. So your answer over here, the moment of inertia is equal to 8k pi by 3 into n plus 5. All of these are like, constant terms into r to the power 5. This value is common for A. It is also common for B. I'm removing the left side of the board because we'll require this calculation. So now we need to find out the ratio of A by B, or you have to find out the ratio of B divided by A. In B, the value of n is equal to 5. So you can put 5 on your own. Meanwhile, I'll be done erasing. So you can put 5 on your own, and on A, you can just put 1. So if you write IB divided by IA, keep in mind that the constant part of this thing, this 8k pi by 3, is common. That is going to cancel. The only thing that is going to remain is r to the power 5 by n plus 5. Even the r part is also going to cancel. So this entire part is going to cancel. In the case of B, n is equal to 5. So you will just write, मैं लिख तो देता हूँ पूरा, but you will just know that the constant part is going to cancel out. 8k pi r to the power 5 divided by 3. Put the value of n. So n is equal to 5. 5 plus 5. This is for B. And when you write it for A, I'll slightly change the color so you can see the difference. 8k pi r to the power 5 divided by 3. In the case of A, n is equal to 1. So you will get 1 plus 5. So they say that this answer is equal to k by 10. Find out the value of k. That's what is given in the question. You can see it. This is a JEE 2015 question, I guess, advanced. तो they ask you to find out the value of k. तो यहाँ पे क्या होगा 8k pi r to the power 5. 3 is going to cancel. So you have 1 plus 5 is 6 divided by 5 plus 5 is 10. So the value of k is 6. ठीक है? So that's it for today. Have a great day.